Welcome to our presentation on the Global Trade DLT platform for iron ore. Over the course of the presentation, you will see these acronyms. We have covered them before, but I'd just like to refresh your memory. In the room today, we have John Stevens, COO of BHP, Sean Xiang, Operations Director of Eagle Bulk, Susan Brinskoff, Trade Finance Senior Controller of BNP Paribas, Wang Xiao, the CEO of LBH, and Lucy Gabbins, the Customs Director at HMRC. Thank you all for coming.
To recap, during the last 3 months, we have followed our agenda. In November, we held individual meetings with all stakeholders across the value chain and listened their feedback. Additionally, we conduct a 2-day workshop for each stakeholders involved in the DLT, including DLT vendors, and a 3-day workshop on trade finance, trade documentation, and global iron trade architecture. Regarding all these inputs, we established a preliminary technical blueprint for a multilateral DLT platform. After all this hard work journey, we will continue working together in the definition of our common vision agreed and supported across the value chain entities.
Now a review of our combined effort. Together we are trying to achieve a more transparent, efficient and secure global trade architecture for the buying and selling of iron ore. So how are we planning to achieve this? To a distributed ledger technology platform by distributing vital trade documentation and automating documentation transactions between multiple entities. Iron ore is a standardized commodity with few important international shipping routes and marine agencies, while the market is run by 3 key players. This makes it ideal for automation. The bills of lading are vital to letter of credit financing, and there's almost $479 billion worth of letters of credit sent by the European continent per year. We are proposing London as a base of operations due to its leading metal exchange, strong banking environment, and innovation capital and finance that exists in the city.
So why are we here today? Well, you operate within a disruptive market. Mining companies and other entities such as trade finance banks are targeting new technologies as a method of improving supply chain efficiencies, lowering operating costs, and enhancing working capital flows. We pull out 5 key trends in your industry. The first is we see increasing efficiency in trade documentation flows. The second is that we see an increasing amount of partnerships across supply chain entities. The third is that we see across the industry a drive towards reducing risk of fraud. The fourth is that we see a consistent turn towards product traceability back to origin. And the final one is enhancing trade chain insights and analytics through big data management.
In 2017, the world's largest container shipping company, Maersk and IBM, launched a distributed permission platform called TradeLens, which is designed to promote more efficient and secure global trade, bringing together various parties to support information sharing and transparency, as well as stimulate industry-wide innovation. Using blockchain with smart contracts, TradeLens enables digital collaboration across the multiple parties involved in international trade. TradeLens enables stakeholders to collaborate in cross-organizational business processes and information exchanges, backed by a secure, non-reputable audit trail, thereby creating a trustworthy ecosystem. Cryptography permits access to specific parties while also securing visibility across the ecosystem. Stakeholders interact more efficiently, harnessing real-time shipping data and transparent shipping documents. To comply with regulations and laws, TradeLens collaborates with legal authorities to embed contractual requirements into smart contracts. TradeLens has an industry advisory board consisting of actively involved ecosystem participants who help to promote global standards around an open and neutral solution. TradeLens Early Adopters Program has resulted with IBM and Maersk having 94 organizations participating on the TradeLens platform. The second business case is about Cargill's trade finance transaction using blockchain in May 2018. The transaction involved a bulk shipment of soybeans from Argentina to Malaysia through Cargill's Singapore subsidiary as the purchaser. A letter of credit was issued using Corda by HSBC to ING. Cargill believes that blockchain can help their company to nourish the world in a safe, responsible, and sustainable way. Transaction completed on a single shared application rather than multiple systems, which eradicated the need for paper-based documentation. The exchange was done under 24 hours, unlike conventional procedure that usually takes 5 to 10 days. Instant updates provided an overall better end-to-end contracting visibility, which allowed to achieve transparency and security. In terms of government, the Corda Network Foundation is a separate entity that governs the platform in a fair and neutral structure, thus creating a stable operating environment for parties. Attraction of mass adopters was possible because of encouraged collaboration with other ecosystems stakeholders like regulators, ports, customs, and logistics providers such as large shipping carriers. After the successful completion of trade in 2018, Cargill is planning to adopt the technology across other industries.
Iron ore trade architecture is currently slow, vulnerable to fraud, and complex, as there are 9 opaque stages across the value chain. Trade documentation composed of the bill of lading, commercial invoices, and certificates must be shared among all trade participants, including sellers and buyers, landing banks, freight insurance companies, port authorities, and cargo and shipping agents. Documents can be modified in the process and sometimes even lost. Trade transactions take many days to settle. As a result, global trade is contingent on the efficiency of trade finance, which makes suboptimal use of advanced technology. Complexity has given rise to 4 main pain points, as you all know. First, trade is heavily paper-based with manual couriering of documents and risks of loss or non-availability. Second, there is a lack of transparency with no clear chain of custody of the bill of ladings and no traceable chain of transference of title. Third, trade is subject to high levels of risk and fraudulent activity. Because the documentation travels together with the iron ore, papers are easily forged, stolen, lost, or tampered with. Finally, due to the lack of shared control in the system, one party often has no visibility of the other party's role in the supply chain, resulting in frequent contractual inconsistencies, thus undermining the efficiency of trade, as you all may have experienced.
So to bring this to life, I'm going to talk about the distribution of bills of lading. In this use case, you can see in the top that the buyer's bank transfers a letter of credit to the seller's bank as a form of guarantee for the goods. As a result, the buyer's bank is to receive the commercial invoice, the bills of lading, which are the ownership to the goods, and the certificates from the seller's bank. Now in this case, the seller's bank is in China and the buyer's bank is in Brazil, meaning that the documents have to be transferred either by courier or over electronic submission. This can lead to delays in shipping, a potential loss of documentation, an insecure electronic transmission, and also a collateral credit risk incurred by the buyer's bank. Now, when we apply DLT in smart contracts, we can see that the buyer's bank still transfers the letter of credit to the seller's bank as a form of guarantee, but the smart contract automates the delivery of the bill of lading and the other documentation to the buyer's bank. And this transaction is recorded on the append-only log within the global DLT platform, as highlighted with the red oval between the certificates and the buyer's bank. This means that there is real-time automated delivery of the buyer's bank collateral in terms of the bill of lading and the other documents. There's complete transparency of stage of trade across all parties. We can see that there's distributed append-only log data on the global DLT platform, which is immutable. And there's also an overall automated process between the sellers and the buyer's bank with inherent trust in the programmed smart contracts. We will now cover why our solution is better than other technologies within this domain area. DLT, like other technologies, has its limitations. However, we believe in its applicability within the iron ore trade. It is important to note that if DLT is applied correctly among the right partners, it could reduce ecosystem trade operating costs by up to 50 to 70%. Our research shows that DLT solves the 7 applicability criteria, which determine the application of DLT within the iron ore trade and trade finance field. A federated DLT with embedded smart contracts support the fulfillment of existing challenges regarding transparency, decentralization, and resistance to censorship. By providing visibility with an immutable record, there is no single point of failure across trusted nodes that are privy to the close ecosystem. Our solution provides for auditability of records, interoperability, and resilient security across a federated DLT system, which is both scalable to facilitate international trade transactions, which often occur simultaneously across different time zones.
What does this solution achieve? The main value creation comes from mitigating the previously discussed pain points. To exemplify the value creation, we will go into 3 business cases for our proposed DLT platform. The first is digitization of trade-critical documents. Our proposed solution eliminates the risk of losing documents in transit and creates a traceable chain of title reference. It also mitigates the risk for fraud. According to Bain Consultancy, DLT can facilitate about $1.1 trillion in new trade volume. The second business case relates to smart contracts. Current pain points are, among other things, the non-availability of documents when needed, unclear roles and responsibilities, and multiple and non-integrated trade platforms. In 2018, 26% of trade finance transactions were wrongly rejected. Smart contracts will be able to mitigate this and therefore reduce transaction costs. The third business case relates to the automation of key business processes. This reduces the complexity of the cases resulting of the multitude of parties and contractual inconsistencies. The World Economic Forum estimates that automated documentation trade will open $0.9 trillion due to better service levels and lower fees.
So what data is within each block on our platform? Well, in this example, I focus on a bill of lading. On the left, you can see an original bill of lading, which, like all other bills of lading, has 12 key data points. In this example, I'll focus on the consignee and notify party, i.e. number 5. This refers to the person who owns the bill of lading at any point in time. In this example, it's Susan Marley. So how is this data represented in the block? Well, first of all, we have to take this raw data, as shown in the video, and run it through a hash algorithm. We use SHA-256, which spits out a 32-byte ID. But when we want to transfer the ownership of this bill of lading to Adam Johnson, we insert Adam Johnson into the raw data, and it will spit out a completely different ID number. So what if we have multiple transactions at any one point in time within the block? Well, we use Merkle trees to append similar transactions to the platform. So as you can see here, we have a Merkle tree hash which represents all the transactions within this block of transacted transfer of bills of lading ownerships. So we can see that transaction A has been hashed to represent hash A Susan Marley and hash A Adam Johnson, and we have transaction B, which is to refer to the transfer of ownership from John Smith to Stephen Marks. We then hash transaction A and transaction B to give us an overall block hash, which is Merkle tree AB here. This means that if we were to change any of the data from the transfer of ownership in hash A, it would completely void the entire Merkle tree, which is why blockchain is a very good solution for us.
So to take the solution forward, stakeholders must evaluate the alternative courses of action. On one end, the first option is to do nothing and keep trade as is. This option would avoid heavy capital expenditures and would sustain current organizational setup, but would also have the drawback of maintaining high levels of trade finance and supply chain costs. Another alternative, on the other hand, would be to seek alternative technologies to the use of DLT, with the possibility to find less complex and less expensive, readily available technology. However, such option risks not solving the problem at all and creating industry bottlenecks and the need for further higher investments in the future. We thus recommend the development of a proof of concept of a DLT trading platform through the constitution of a joint venture. This strategy can provide first mover advantage and reduce trade finance and supply chain costs, but will require investment and coordination among all stakeholders. So you must be asking yourselves, why a joint venture and why a proof of concept? The joint venture will act as the governing body that manages the ledger, defining standards, well-defined roles, the provision of information that will be encrypted in the blocks, and capital contributions. The structure of a JV facilitates the payment of nodes as incentives to each stakeholder through the administration of costs and returns. A proof of concept allows for a controlled development scope to address the main technical challenges of a smart contract. It enables the development of performance metrics in beta and controlled environments, designed to measure the real extent of the reduction of transaction costs and avoiding high capital expenditures in the beginning. If all of you agree on this strategy, we suggest the next step would be to conduct an in-depth feasibility study intended to serve decision-making about how to meet identified requirements. There are a number of dimensions of feasibility that will need to be considered if a decision is to be made. Technical feasibility, which includes decision on infrastructure, architecture, and data entry processes. Legal and regulatory feasibility to make sure that the DLT application is in compliance with national and international regulations in all jurisdictions. Financial and economic feasibility to measure the expected return on investment. Governance and managerial feasibility to ensure that the necessary managerial capabilities are in place and to aid on the decision-making process. And finally, the social feasibility, which relates to the acceptability of change by users and managers.
Although we will target the distribution of trade documentation initially, we are working towards a target operating model as shown in this slide. We envisage a future with permissioned access across the entire ecosystem. And with this, I would like to thank you for your time, and we value your continued participation.